Welcome to Algaeomala's Prep Academy. Today we'll be going over the root test for series. The root test for series states that when we let the summation of a sub n be a series, the series of a sub n will converge absolutely if the limit as n approaches infinity of the nth root of the absolute value of a sub n is less than 1. The root test also states that the series of a sub n will diverge if the limit as n approaches infinity of the nth root of the absolute value of a sub n is greater than 1. The third rule of root test is that the root test is inconclusive if the limit as n approaches infinity of the nth root of the absolute value of a sub n equals 1.
For our first example, the term of the series is to the nth power, which means that the root test would be easily applicable. We will let the term of the series be a sub n here. First, you take the limit as n approaches infinity of the nth root of the absolute value of a sub n. By doing this, the nth root and the nth power will cancel out. After that, you just continue simplifying. Once everything is simplified, you get the limit as n approaches infinity equals 5 over 2, which is greater than 1. Therefore, the series diverges by the root test.
Our second example will be using the root test on the summation of negative 7n plus 3 over 9n minus 3 to the nth power. The root test can be used since the a sub n is to the nth power. First, we have to find the limit as n approaches infinity of the nth root of the absolute value of a sub n. We can plug in our known a sub n into the generic equation, which cancels out the nth root and the nth power. From here, we just simplify our limit. Once we simplify our limit, we find that the limit as n approaches infinity of our a sub n is 7 over 9, which is less than 1. And since our limit is less than 1, we can say that by root test, our summation of negative 7n plus 3 over 9n minus 3 to the nth power converges.
For our next example, since the series is to the nth power, we are able to use the root test. Let the series equals a sub n, then take the limit as n approaches infinity of the nth root of the absolute value of a sub n. We are then able to cancel out the n's. After this, plug in infinity, then simplify. This will give us a value of infinity, which is greater than 1. Therefore, the series diverges by the root test.
So our next series is infinity, sigma n equals 1, 2n over 2n plus 3 to the nth power. So we plug it into the formula, limit as n approaches infinity, the nth root absolute value, 2n over 2n plus 3 to the nth power. Since the nth root and nth power cancel out, you're left with the limit as n approaches infinity, absolute value, 2n over 2n plus 3. Plug in infinity, you get 2 times infinity over 2 times infinity plus 3 absolute value, so 1 equals 1. Therefore, in the series infinity, sigma n equals 1, 2n over 2n plus 3 to the nth power is inconclusive by the root test.
Therefore, try another test.
Today's lesson was taught by
Choco Boy.
Blaster.
Phantom.
and Rise. Please like and subscribe.
Thank you for watching.